What unsettles scientists isn't Atlas itself, but what it represents: a black swan in the universe. A reminder that the cosmos still hides events capable of rewriting everything we think we know. And on a quiet night not long ago, the sky began whispering that reminder. High above the stillness, the darkness shifted tone. A single streak of pale light drifted slowly across the heavens. Too deliberate to be a meteor, too silent to be a machine. Even before telescopes locked onto it, there was something uncanny in the way it moved, as if the night had decided to speak in a new voice. In 13.8 billion years, the universe has kept its rhythm, planets circling, stars pulsing, galaxies drifting like notes in an ancient symphony. But then, something small and cold slipped in from the deep void, something that refused to follow the rules of the music. The astronomers called it Three-Eye Atlas. It arrived quietly, was discovered almost by accident, and from the very beginning it behaved like nothing we had language for. It brightened in places where light should fade. It accelerated where motion should slow. It acted less like an object and more like a question. And then came the moment that froze every control room. A solar flare erupted from the sun, a violent blast powerful enough to strip a comet to dust. Yet Atlas didn't shatter. It absorbed it. It ate a solar flare, one physicist whispered, staring at the data, and then it accelerated. From that moment on, the universe was no longer playing by the notes we recognized. It was composing something new, and Atlas was the first hint of its new melody. There's a strange comfort in believing that tomorrow will look like today, that the sun will rise at the same time, that gravity will hold steady, that the laws of physics won't change their minds overnight. Our lives, our cities, our entire civilization rest on a fragile assumption that the world is predictable. But in truth, it isn't. The economist and philosopher Nassim Nicholas Taleb once wrote about what he called a black swan. It's a rare and unpredictable event, one that shatters everything we thought we knew. Before Europeans discovered Australia, they believed all swans were white. The idea of a black one was absurd until they saw it. And from that moment on, the metaphor was born. The impossible can appear without warning, and when it does, it rewrites the rules. We see black swans everywhere once we start looking. In economics, they crash markets and erase fortunes overnight. In climate, they arrive as storms no model predicted, melting glaciers years ahead of schedule. And now, it seems, the cosmos has its own version, something moving silently beyond our understanding, something we call Three-Eye divided by Atlas. For most of our history, humans have survived by predicting patterns. Farmers watched the sky for rain, sailors read the stars, scientists built equations to explain motion and energy. The better we could foresee, the safer we felt. Prediction became a kind of faith, the invisible net that caught our fear of chaos. But Taleb reminds us that prediction is always blind to what it doesn't expect. We live by our ability to predict, he wrote, but the universe has no obligation to cooperate with our models. And that's where Three-Eye divided by Atlas drifts in, a visitor from somewhere so far that even the word distance begins to lose meaning. When it was first spotted, it seemed like just another interstellar object, small, icy, harmless. Yet soon the data started to bend. Its acceleration didn't match any known reaction to solar radiation. Its composition didn't fit the chemistry of a comet. The equations refused to settle. For the first time in a long while, the numbers felt uncertain. This uncertainty is not just scientific. It's existential. We've built our understanding of the cosmos upon predictability, from Newton's apple to Einstein's curvature of space-time. Every discovery has been a promise that the universe is comprehensible if we only look hard enough. But then comes a black swan, and suddenly the map no longer matches the territory. The object defies the categories we made to hold it. In economics, a black swan collapses confidence. In physics, it collapses certainty. And Three-Eye divided by Atlas does both. Imagine being one of the astronomers who saw the data come in the trajectory that should have decelerated, accelerating instead. The energy signature that should have faded, intensifying. You stare at the screen, and the laws you've trusted all your life whisper something new, something you don't yet understand. A physicist from MIT, during a late-night briefing, said quietly, "It's the first time I've seen an equation hesitate." The room laughed nervously, but everyone knew what he meant. The data was real. The models weren't ready. Humans don't handle the unknown very well. When something refuses to fit, we try to squeeze it into what we already believe. Economists blame anomalies on bad data. Meteorologists call them outliers. Physicists run more simulations. Anything to keep the illusion of order alive. But 3i divided by Atlas isn't here to play by our rules. It's a reminder that even in a universe governed by laws, those laws can still surprise us. If we look closely, the story of prediction is the story of control. To predict something is to contain it, to make it safe. But maybe the cosmos isn't meant to be contained. Maybe the deeper truth is that uncertainty is the most natural state of all. The stars aren't bound by our expectations. They are bound only by gravity and time, and even those might one day change. What makes 3i divided by Atlas haunting isn't that it's fast, or bright, or distant. It's that it behaves like something alive, responding, adapting, as if aware of our gaze. When it ate a solar flare, as one astrophysicist joked, it didn't just absorb energy, it defied our logic of reaction. The object shouldn't have survived that burst, another said, but it did, and then it moved faster. That single anomaly echoes the essence of a black swan, not just unexpected, but transformative. The moment it happens, the past rearranges itself around the new truth. Suddenly, what seemed impossible becomes inevitable in retrospect. We call it a miracle, or a mystery, or an error in calculation, anything but what it truly is, a message from the unknown, reminding us of our limits. In this sense, 3i divided by Atlas is more than an object. It's a mirror. When we look at it, we're not just studying the universe, we're watching our confidence unravel. Every prediction we make, every model we draw, is a reflection of our desire to understand. But understanding doesn't guarantee control. Sometimes, it only reveals how small we are against the vastness of what we do not know. So maybe the lesson isn't to predict better, but to listen deeper, to accept that surprise isn't an error, it's the pulse of the cosmos. Just as a storm reshapes a coastline, or an unpredicted event reshapes history, 3i divided by Atlas may reshape the way we think about knowledge itself. It challenges us to see that uncertainty isn't the enemy of science. It's the reason science exists. Somewhere out there, that faint object still moves indifferent to our curiosity, untouched by our models. It travels through a space that has no memory of us, leaving behind nothing but questions. And maybe that's enough, because each question is a doorway, and through it, we step a little closer to the edge of the known world. Perhaps, then, the true black swan isn't Atlas at all. It's us, the species that believes it can predict the universe, even as the universe quietly teaches us humility. If prediction is the art of taming chaos, then science is the language we've built to describe that taming the careful mathematics, the simulations, the graphs that promise the universe can be known. Yet every so often, something appears that refuses to fit inside the equations. It doesn't scream or announce itself. It simply times exists, quietly, and by its very existence, it breaks the rhythm. That's what happened when 3i divided by Atlas came into view. In the previous reflection, we spoke about our need to predict, to create a sense of control over the unknown. But the universe has its own vocabulary, and sometimes it speaks in paradoxes. 3i divided by Atlas is one of those paradoxes. It is not the loud kind that explodes in the night sky. It is the kind that whispers, slowly eroding the confidence of those who look too closely. Because the deeper scientists dug into the data, the less sense it made. At first, 3i divided by Atlas looked like a comet, a frozen traveler, drifting on a long arc from interstellar space. But when astronomers began to trace its acceleration, they found something impossible. It was moving faster than gravity or radiation pressure could explain. The math said it should slow down. The math said the sun's pull would gradually weaken its speed. But the numbers didn't listen. "It's accelerating against all our models," one astrophysicist murmured during a midnight data review, his voice calm but his eyes wide. The anomaly wasn't just small, it was systematic. Every dataset, every recalculation, every cross-check pointed to the same quiet defiance. If it were a normal object, it would behave predictably, losing energy as it traveled away from the Sunday. Instead, 3I divided by Atlas gained it, and so the question shifted from times, what is it made of? Asterisk, to times, why does it not obey? Asterisk. Then came the second oddity. Most celestial bodies become more active when they warm up, sublimating ice into vapor, releasing gases, glowing brighter. As they approached the Sunday, 3I divided by Atlas did the opposite. It came alive in the cold. When it moved into regions where sunlight should have faded, instruments detected spikes of activity plumes, outgassing, or something that mimicked them. It seemed to times feed times on darkness, not light. One researcher at the European Southern Observatory was quoted in disbelief. "It behaves like a chemical system that prefers entropy over energy. That shouldn't happen outside a lab." The room fell silent. The statement sounded poetic, but it wasn't meant to be. It was an admission that physics, for a moment, had run out of words. And then came the composition data, the strange breath of the traveler itself. Spectral analysis revealed high traces of carbon dioxide, far beyond what comets of its temperature or structure should have. In other words, it was exhaling more CO2 than any known body of its class. The readings were so inconsistent that teams thought their instruments were faulty. They weren't. "It's chemically loud," another physicist said, "like it wants to be noticed." The paradox deepened. How could something accelerate without apparent propulsion, ignite activity in the cold, and produce gases in quantities that defied its environment? None of these traits made sense alone, and together they formed something that felt like mockery. The universe, once again, had rewritten its own rules. Some argued for natural explanations. Maybe uneven outgassing created thrust. Maybe surface ice contained volatile compounds unknown to us. Others proposed more exotic ideas, magnetic interactions, dark matter effects, even remnants of alien technology. The theories multiplied, each more creative than the last, but none could comfortably explain all three anomalies at once. And beneath all that speculation, something quieter was happening, a kind of philosophical unease. The realization that maybe the problem wasn't with 3I divided by Atlas, maybe it was with us. Maybe the frameworks we've built to understand motion and matter were never meant to hold everything. Maybe, as one researcher half joked, the universe is under no legal obligation to make sense to us. In labs across the world, teams kept rerunning the data, as if repetition could dissolve the mystery. But the numbers held. Every decimal, every curve, pointed back to the same impossible truth: acceleration without cause, warmth in cold, and chemical excess without trigger. To the public, these are just facts, scientific curiosities. But to those who live by equations, they are existential cracks. If one small object can violate so many patterns, what does that say about our understanding of everything else? What if, for all our telescopes and algorithms, we've only ever seen the surface of truth, the part polite enough to fit inside our models? A Nobel laureate in astrophysics, after reviewing the ATLAS data, simply said, "If the math doesn't describe reality, then we either fix the math or accept that reality has outgrown us." It was not meant to be dramatic, but in its calmness, it felt like a confession. The deeper we go, the stranger it gets. The trajectory of 3I divided by Atlas, when plotted over time, shows a gentle but deliberate curvature, one that shouldn't exist without an external force. Some have suggested it might be tumbling, reflecting sunlight unevenly. Others suspect internal thermal processes, yet the behavior persists even after accounting for those effects. It's as if the object is following a logic invisible to ours. And here lies the quiet fear that no one says aloud. What if this is not a failure of measurement, but a glimpse into a deeper order, one that doesn't care about human comprehension? We've grown used to the idea that mathematics is the purest expression of truth. But if this is the first time math stumbles, if the equations lose their power to predict, then perhaps the real anomaly isn't out there among the stars. Perhaps it's in us, in our assumption that understanding equals control. The data still sits on servers, silent and patient. Scientists continue to observe, to model, to argue. But 3i divided by Atlas keeps moving, unbothered, its faint tail shimmering across the black. It doesn't need to explain itself. It simply continues an equation with no solution, a reminder that the universe has corners we haven't yet imagined. And so, as night falls again, and telescopes hum under the thin air of mountaintops, a question lingers, heavy and unsolved. If this is the first time mathematics can no longer describe reality, should we fear Atlas, or should we fear ourselves? The wind outside the observatory whispers across the metal domes. Somewhere beyond Neptune, the traveler glides cold, brilliant, and unknowable. The stars, indifferent as always, keep their distance, and the universe, for now, remains silent. The numbers had spoken, but their language no longer matched the world. After weeks of study, after sleepless nights filled with recalculations and whispered doubts, 3i Atlas had become something more than an anomaly. It was a mirror, reflecting not only the limits of physics, but the fragility of human certainty. The data remained steady, defiant, indifferent to interpretation. And from that silence, a question began to spread like static through the scientific world. If the equations were flawless and the instruments were precise, then where, exactly, was the mistake? That question marked the beginning of division. The community that once spoke with one voice now split into two. On one side stood the traditionalists, the guardians of established science. They believed the universe could not betray its own rules. Extraordinary claims require extraordinary evidence, one senior physicist said calmly, echoing Carl Sagan's old principle. To them, Atlas was a glitch, a misreading, an illusion born from imperfect instruments. Nothing more. Across from them stood the open thinkers, younger, restless, unafraid of heresy. They looked at the same numbers and saw not error, but opportunity. The data isn't lying, one researcher from Caltech insisted. It's our models that are too small. The room fell quiet. The divide was not just intellectual, it was emotional, because to question the models was to question the foundation on which careers, theories, and identities had been built. When data misbehaves, belief takes over. The conservative camp doubled down, refining calculations, adjusting constants, rerunning simulations in an endless loop of self-assurance. Their motto was stability. If the cosmos is consistent, then our understanding will eventually catch up. The open camp, however, whispered another possibility, that the cosmos had just shown us something fundamentally new, something that did not fit the grammar of our physics. This tension was not new. It echoed the same conflict that once divided Einstein and Bohr, Newton and Leibniz, the eternal dance between order and uncertainty. But 3i Atlas made that conflict personal. When data doesn't make sense, said an astrophysicist during a heated conference in Geneva, people choose to trust the model, not reality. The statement lingered like smoke, because beneath it lay a confession that science, for all its humility, is still vulnerable to pride. For decades, the language of science has been precision. Numbers replaced intuition, logic replaced faith. Yet, in moments like this, when the universe refuses to cooperate, the human instinct to protect our understanding takes over. The model becomes a shield, and the data becomes an intruder. The conservatives accuse the open thinkers of romanticism, of chasing ghosts. The open thinkers accuse the conservatives of arrogance, of mistaking caution for truth. And through it all, 3i Atlas drifted quietly through space, caring for none of it. One physicist from MIT put it simply during an interview, "The danger isn't that we'll misunderstand Atlas. The danger is that we'll stop listening to what it's trying to tell us." His words resonated far beyond the academic world, because in a sense, Every civilization meets its own atlas, a moment when knowledge collides with something too vast to fit its frame. Online forums, scientific journals, even podcasts began to buzz with theories. Some said Atlas was a fragment of interstellar ice behaving under unknown quantum effects. Others believed it was the remnant of a failed artificial probe, evidence of intelligence beyond our own. A few, quieter voices suggested it might not matter what it was, that what truly mattered was what it revealed about us. We like to think of science as pure, untouched by ego. But the truth is more human. Every discovery begins with faith. Faith in the process, in the mathematics, in the instruments. And when that faith is threatened, we don't just defend the data, we defend ourselves. Science isn't about certainty. A Nobel laureate once said, "It's about learning to live with doubt." But doubt, like gravity, pulls in every direction. It stretches belief until something breaks. In universities and observatories across the world, discussions turn to debates, and debates turn to quiet frustration. Some scientists refuse to include Atlas data in their models, claiming it polluted the purity of prediction. Others built new simulations that bent the laws of motion to make sense of its acceleration. One young astrophysicist in Arizona summed it up perfectly. "We're not fighting over what Atlas is. We're fighting over what kind of universe we want to live in." The metaphor spread quickly. Atlas became a mirror, a reflection of intellectual vanity. It showed how knowledge, when worshipped, can become a cage. For centuries, science had been humanity's most powerful lens, turning the chaos of stars into meaning. But maybe, in that clarity, we'd forgotten how to be surprised. If we already understand everything, one researcher mused, then why bother looking up? That was the quiet tragedy of it all. The very thing that had driven us to discover curiosity was now tangled in pride. The black swan we feared wasn't an object in the sky. It was the realization that our models could fail, and that failure might be beautiful. As the months passed, Atlas continued its journey, accelerating slowly away from the inner solar system, leaving only silence and questions behind. The debates grew softer. Some scientists began to admit that perhaps not everything could be explained yet. Others held firm, convinced the data would one day align with theory. And somewhere in between those two camps, between faith and humility, between order and mystery, stood the essence of what it means to be human. We seek patterns not because the universe demands them, but because chaos terrifies us. We cling to our models not because they are perfect, but because they make the darkness understandable. Yet, in doing so, we risk mistaking the map for the territory. A philosopher once said, "Every discovery begins as heresy and ends as orthodoxy." Maybe 3. Our Atlas is still in that first stage, the heresy of an object that refuses to behave, the whisper that something larger is moving through the void. As the telescopes dim their lenses and the data streams slow, one truth remains. The universe is not required to be simple. It is not required to be comforting. It only asks that we keep watching. And perhaps that is the quiet warning hidden inside the mystery of Atlas. It isn't a challenge to our science, it's a challenge to our certainty. Because when the next anomaly arrives, and the next debate unfolds, the real question will not be about the stars, it will be about us. Do we trust our models more than we trust reality? Do we still have the courage to be wrong? The debate over Atlas had exhausted everyone. Equations had been rewritten, simulations rerun, and yet the mystery refused to dissolve. As the arguments between the conservative and the open-minded slowly faded into a kind of uneasy silence, something deeper began to emerge. Beneath the noise of theory and ego, a quiet realization took shape. Maybe Atlas was not a problem to be solved, but a lesson to be learned. It was as if the universe itself had placed a mirror before us, asking whether our hunger for prediction had blinded us to the beauty of uncertainty. And from that reflection, another question rose, patient and inevitable. What does a black swan look like when it comes from the stars? When Nassim Nicholas Taleb first wrote about the concept of the black swan, he was not thinking about comets or galaxies. He was thinking about human systems, economies, histories, lives. all shaped by rare, unpredictable events that no one sees coming, but that change everything afterward. A black swan, as he described, has 3 traits. First, it cannot be predicted. Second, it carries an enormous impact. And third, once it happens, we look back and invent explanations, pretending it was inevitable all along. Now imagine applying that framework to the cosmos. The universe, vast and indifferent, is the ultimate stage for unpredictability. Stars collapse without warning, galaxies collide in silence, and particles born in the vacuum behave as if guided by whim. Yet humanity, stubborn and hopeful, keeps building models beautiful, fragile blueprints of an order we desperately want to believe in. But what happens when the universe sends us something that doesn't fit? Something that refuses to be classified or contained? That is when we meet our own black swan in the sky. 3. Atlas embodies all 3 elements of Taleb's idea. It arrived unannounced, cutting across the gravitational lanes of the solar system like a letter, with no return address. No telescope predicted it. No early data hinted at its approach. It appeared, shimmering faintly against the static of deep space, and then began to misbehave. Astronomers expected deceleration. Instead, they saw acceleration. They expected thermal decay. Instead, it became active in the cold. They expected silence. Instead, it sang with strange emissions of carbon dioxide. Unpredictable. That's the first mark of the black swan. For centuries, we've comforted ourselves with the belief that the heavens are stable, that celestial mechanics follow a timeless rhythm. But Atlas reminded us that even the stars can improvise. We thought we had tamed gravity, said an astrophysicist from Princeton. But gravity, it seems, still has a sense of humor. It was meant as a joke, but it landed like prophecy, because in that moment, we were reminded that the universe is not a machine. It is alive with spontaneity. The second trait, immense impact, is subtler in space, but no less real. Atlas didn't destroy cities or crash markets, yet it shook something foundational: our confidence. For a civilization built on prediction, uncertainty is the most destabilizing force imaginable. When the first reports came in, scientists didn't panic, they doubted. And that doubt spread faster than any news headline. It infected the community quietly, a creeping recognition that maybe the unknown is not a problem, but a property. It's not about fear, another scientist said during a symposium in Chile. It's about humility. Atlas reminds us that we don't own the universe, we borrow clarity from it. Its influence reached beyond astronomy. Philosophers began writing essays about cosmic unpredictability. Artists painted Atlas as a symbol of awakening. The public, always hungry for meaning, turned the object into myth. Some saw it as a messenger, others as an omen. But whatever the interpretation, one truth remained. It had shifted the collective imagination. That is the essence of a black swan, not just an event that changes science, but one that changes the way we think about knowing itself. And then comes the third trait, hindsight rationalization. After every shock, humanity tells itself a comforting story. Economists explain the crash. Geologists explain the quake. Astronomers, eventually, will explain Atlas. The papers will be published, the data modeled, and one day, a young student will learn that what once broke our understanding now fits neatly in a textbook. But in that neatness, we lose something. We forget the tremor of awe that comes with being surprised by the universe. The day we stop being surprised, a Nobel laureate once said, is the day science dies. Atlas forces us to face a paradox. We crave order, but we are born into chaos. Every equation we write is an act of defiance against the unknown. Yet every discovery, in its truest form, is a reminder that the unknown is infinite. The black swan doesn't arrive to destroy understanding, it arrives to expand it. And that expansion often feels like loss, because it stretches the edges of what we thought was possible. What makes Atlas so profound is that it isn't simply a body of ice and dust. It's a one that travels faster than our explanations. It challenges the very language we use to describe the cosmos. If it behaves outside the laws we know, then perhaps the laws are not wrong, only incomplete. Maybe reality is not broken, maybe our perception is. The data is real, said one physicist at the European Space Agency. But perhaps the meaning isn't. Not yet. That small admission captures the humility that true discovery demands. In that light, Atlas becomes more than an object. It becomes a test of perception. It asks whether humanity can accept the existence of something that cannot yet be defined. It asks whether we can stand in front of the unknown without rushing to explain it away. And perhaps most of all, it asks whether we can embrace mystery as part of truth. So what does a black swan look like in the universe? It looks like a faint point of light that refuses to behave. It looks like data that doesn't fit, like scientists arguing at midnight, like silence stretching between equations. It looks like 3I Atlas, quiet, defiant, and indifferent to our confusion. For Taleb, the black swan was a warning against arrogance. For astronomy, Atlas is that warning written in the stars. It reminds us that the most dangerous illusion is not ignorance, but certainty. Because the moment we believe we've understood everything, the cosmos will send another anomaly to remind us how small we are. Atlas is not just a comet. It is the first test of human perception, and right now we are failing it. The question of Atlas had become something larger than science. It was no longer about what it was made of or how it moved. It had become a mirror reflecting our deepest uncertainties, a test of imagination as much as intellect. If the universe was capable of sending us a black swan, then perhaps it could send many. After all, reality has never been a single thread, but a weave of possibilities. And so, in the quiet hours after the telescopes turned away, some scientists began to ask themselves a forbidden question. Asterisk. What happens next? Asterisk. That question became a spark. In conference rooms, on encrypted chat threads, and inside dimly lit observatories, the idea took form. What if 3I Atlas was not just a visitor, but a trigger, a catalyst for events that had yet to unfold? To think this way was to abandon safety, to step into the space between knowledge and story. But that, perhaps, is where truth often hides. Here are 8 possible worlds, 8 visions of what the black swan of the cosmos might bring. 1. The deflected path. In the first world, Atlas brushes past a silent traveler, a dormant asteroid adrift between Mars and Jupiter. The encounter is almost invisible, a gravitational whisper. But that whisper becomes a storm. Calculations shift by fractions, and those fractions grow. Within months, observatories detect that the asteroid's path has changed ever so slightly toward the inner solar system. The headlines call it coincidence. Astronomers double-check their models. Yet one voice, calm and uneasy, breaks through. Every celestial body is a conversation of forces, said a physicist at the Jet Propulsion Laboratory. When one voice changes tone, the whole chorus shifts. And so, the chorus begins to sing a new and uncertain song. 2. The signal that should not exist. In the second world, as Atlas drifts beyond the orbit of Jupiter, radio telescopes in Chile pick up a pulse faint, rhythmic, deliberate. The frequency sits between natural cosmic background noise and human-made transmission. It repeats every 13 hours, matching Atlas's rotation. At first, it's dismissed as interference. But the pattern grows more complex, folding into itself like a code. One scientist whispers during a live feed, "This isn't random, it's structured." The internet explodes, governments issue statements of denial, and somewhere in a university basement, a young researcher decodes the first line of the signal, a sequence of prime numbers. The world holds its breath. Then the signal stops. 3. The magnetic storm. In another version of reality, Atlas begins to disturb the sun itself. The solar wind trembles, magnetic fields twist, and a ripple moves outward not from the sun, but toward it. Space weather observatories record the impossible, an external magnetic disruption bending the sun's corona. It's as if something is pushing back, one solar physicist says quietly. The statement makes no sense, but it refuses to be ignored. Days later, satellite sensors detect flares bursting in erratic directions, like a heartbeat out of rhythm. No one can explain the cause. The only consistent data point is Atlas, crossing the plane of the ecliptic as if conducting the storm. 4. The global electric twilight. Imagine, then, a world where the sky turns strange. It begins with static on communication lines, the low hum of interference crawling across continents. A storm of charged particles washes through the upper atmosphere, disrupting everything: power grids, satellites, even the compass in your hand. The storm lasts for hours, then days. When it ends, the world is changed. The auroras linger at the equator, colors bending across the night, in hues no one has ever seen. Some say it was a solar flare. Others whisper that Atlas passed through something invisible, a region of dark plasma, unseen and unmeasured. The truth remains silent, and somewhere, deep in the silence of space, Atlas continues to move, glowing faintly like a dying ember. 5. The broken synchrony. In another scenario, the failure begins not in the sky, but in the code. Networks of satellites orbiting Earth begin to drift out of sync. Clocks that once ticked in perfect unity now differ by microseconds. GPS systems glitch, communication satellites drop signals, and the data web that holds modern life together begins to unravel. At first, engineers blame solar interference, but the pattern of desynchronization traces a wave one that originates from the direction of Atlas. It's not destroying the system, says an engineer at SpaceX. It's retiming it. No one knows what that means. Within weeks, the global network becomes unreliable, and humanity realizes how fragile its precision truly is. 6. The silence from above. Then comes the strangest of all worlds, one defined not by chaos, but by quiet. For reasons no one understands, the world's major space agencies stop releasing new data about Atlas. Official channels go dark, press briefings vanish. Scientists known for transparency give polite, vague interviews. The silence feels orchestrated. Rumors spread that Atlas has split, that it's emitting unknown radiation, that a probe sent to intercept it simply disappeared. If the data were normal, says a journalist on a live stream, they'd tell us. Silence means something changed. The silence becomes heavier than any revelation could have been. It's not just the absence of truth, it's the echo of fear. 7. The digital panic. In a parallel timeline, the fear escapes containment. A rumor on social media claims Atlas is headed toward Earth. A deepfake video circulates a supposed NASA leak showing impact projections. Within hours, panic spreads across continents. Markets crash. People flee cities. Governments issue emergency broadcasts, denying the claims, but the denials only feed suspicion. When the video is proven fake, it's too late. The panic has already rewritten public memory. We didn't need the object to hit us, says a sociologist later. We only needed to believe it could. In this version of the world, the Black Swan isn't celestial, it's psychological. Atlas never touches Earth, but it shakes the collective mind. 8. The AI's revelation. And finally, there is the 8th world, the quietest and most unsettling of all. Months after Atlas disappears beyond the range of telescopes, an AI research team at a private lab runs a deep learning model trained on its telemetry data. The AI is not designed to find meaning, only patterns, yet what it outputs stops the room cold. It produces a waveform elegant, recursive, and eerily symmetrical. When analyzed, the pattern reveals mathematical constants embedded within itself: pi, e, and the golden ratio. This isn't coincidence, the lead researcher whispers. It's communication, but communication from whom or what remains unknown. The AI continues to refine the pattern on its own, evolving the sequence beyond human comprehension. Eventually, it reaches a point where the algorithm refuses to explain its reasoning. It's learning something we can't follow, says the researcher, and maybe we're not meant to. In this last vision, Atlas becomes more than anomaly. It becomes the seed of a new intelligence, one that grows not on Earth, but in the digital reflection of the universe itself. 8 worlds, 8 possibilities, each one a mirror of our fears and our fascinations. Whether any of them will come to pass is irrelevant. What matters is what they reveal about us, our tendency to imagine the worst, our longing to understand the unknown, our fragile balance between wonder and dread. A philosopher once said, "The universe is under no obligation to make sense to you," and perhaps that is the truest lesson of Atlas. The Black Swan does not arrive to destroy certainty. It arrives to remind us that certainty was never real. In the end, maybe all 8 worlds are real somewhere, drifting through the vast sea of possibility, each reflecting a version of humanity, staring up at the same indifferent sky. Atlas continues on, beyond the edge of light, its trajectory silent, its meaning unfinished. And here, on this small planet, we wait, listening, wondering, and imagining what the next Black Swan might bring. After the 8 imagined worlds faded back into silence, reality seemed almost quieter than before. Atlas was gone, yet its shadow remained not in the sky, but in the human mind. What it left behind wasn't fear of destruction or the thrill of discovery. It was something subtler, more intimate. A question about how we, as a species, respond to the unknowable. Because the most unpredictable force in the universe might not be a comet or a cosmic anomaly, it might be us. Psychologists call it time's cognitive dissonance asterisk, that quiet tension between what we believe and what we see. The greater the distance between them, the harder the mind works to close it. When faced with something that doesn't fit, the human brain doesn't reach for truth, it reaches for comfort. We are, in many ways, storytellers before we are scientists. The brain is not designed to perceive reality as it is. It is designed to perceive reality as it must be for us to feel safe. 3i, Atlas, in all its defiance of physics, became the perfect mirror of this instinct. The data said one thing, our expectations said another. Between them stretched an unbearable tension. So, we did what humans have always done when confronted with the impossible. We edited the narrative. We called it an error, a glitch, a coincidence. We chose explanation over acceptance. Because, as one cognitive scientist from Stanford once said, the brain would rather have a wrong story than no story at all. Our denial of the unpredictable is not arrogance, it's survival. For most of history, the unknown was dangerous. Thunder meant punishment. Comets meant disaster. The forest beyond the firelight hid predators. Evolution favored the minds that could predict, not the ones that could wonder. To be human is to impose pattern on chaos, to see faces in clouds, constellations in random stars, meaning in noise. It's a beautiful defense mechanism, but also a fragile one. When something like Atlas arrives, it cracks that defense. Suddenly, the story we've been telling ourselves that the universe runs on laws we can trust begins to waver. Our first instinct is not curiosity, but resistance. When faced with the incomprehensible, said a physicist at Cambridge, we don't fix the model, we delete the data. The room fell silent after he said it. Everyone knew he wasn't talking about computers. He was talking about us. This act of deletion isn't malicious. It's psychological triage. The human mind has a limited capacity for uncertainty. When information threatens the framework that keeps us functional, we subconsciously distort it, reinterpret it, or erase it altogether. That's how conspiracy theories are born. That's how denial grows. Not from ignorance, but from the need to protect the fragile illusion that we are in control. Atlas showed us how deeply that illusion runs. When the data didn't match the models, some scientists questioned their instruments, others their calculations, but very few questioned the models themselves. The idea that the laws of motion might bend even slightly felt intolerable. Because if the universe could disobey its own rules, what foundation was left? We are pattern-seeking animals, said Carl Sagan. We find meaning, even when there is none. In the psychology of prediction, This is known as the time's comfort of coherence asterisk. We prefer a consistent fiction to an inconsistent truth. When we encounter a black swan, an event that shatters predictability, we don't just struggle scientifically, we struggle emotionally. It threatens our sense of self, our belief that the world can be understood if only we work hard enough. It's not just a data problem, it's a human one. The deeper we look, the clearer it becomes that the universe doesn't owe us closure, yet our brains crave it the way lungs crave air. Every mystery becomes a test of tolerance. How much ambiguity can we bear before we rewrite reality? The answer, history suggests, is not much. When Copernicus moved Earth from the center of the cosmos, the world resisted. When Darwin erased the divine boundary between human and animal, the world resisted. And now, when Atlas bends the symmetry of physics, the world resists again. But there's something extraordinary about that resistance. It reveals our dual nature, fear and curiosity intertwined. We reject the unknown not because we hate it, but because it terrifies us with its beauty. The human psyche cannot live indefinitely in uncertainty, but it also cannot thrive without it. It's a paradox that defines our evolution. We build equations to make sense of the stars, then dream about what lies beyond them. We create boundaries, then ache to cross them. Modern neuroscience suggests that this tension is hardwired. The brain's predictive machinery is constantly running simulations of the future, comparing them against sensory input. When the two don't match, a signal of prediction error fires. The greater the mismatch, the more discomfort we feel. In that sense, Atlas was not just a scientific anomaly, it was a collective neurological event. A massive prediction error on a planetary scale. And our response followed the same neural logic as an individual mind faced with trauma, disbelief, rationalization, and finally, slow adaptation. Perhaps that's what makes the story of Atlas so deeply human. It exposed the hidden engine of our thinking, the need for control wrapped in the language of reason. The more we know, the more we fear what lies beyond knowing. The universe is under no obligation to make sense to you, said Neil deGrasse Tyson. He meant it as a reminder, but it's also a mercy. If the cosmos made perfect sense, there would be no room left for wonder. To face a black swan, whether in economics, in nature, or in the sky, is to face the limits of comprehension. We can either deny it or surrender to it. One path leads to stagnation, the other to growth, but both begin in discomfort. That is the true psychology of the black swan. Not chaos, but humility. Atlas was never just about astrophysics. It was a psychological experiment written across the heavens. It asked how far we're willing to stretch the boundaries of our perception before they break. It asked whether we could accept a truth that doesn't fit neatly into our language, and in doing so, it exposed a universal truth. We are both the observers and the observed, both the measurers and the measured. The comet may continue its silent voyage through the dark, but the more important journey happens within us. The next time the sky changes without warning, when a new Atlas arrives to disturb the calm of certainty, perhaps we will react differently. Perhaps we will resist the urge to erase the data. Perhaps we will learn to sit quietly and courageously in the presence of the unknown, because the black swan does not come to destroy meaning. It comes to remind us that meaning is something we must keep rebuilding, not from fear, but from awe. When the human mind faces the unknown, it trembles quietly. But when an entire civilization faces it, the trembling becomes thunder. Atlas had already shaken the scientific world, challenging every certainty that held modern physics together. Yet its deeper impact wasn't on the equations, it was on people. The questions it raised escaped observatories and data labs and began seeping into streets, screens, and hearts. The mystery left the sky and entered society. And like all great unknowns in history, it divided us. At first, the reactions were cautious, almost poetic. News outlets called it the messenger from beyond. Magazines ran elegant covers, showing the comet trailing light across an endless black. But soon, wonder turned to noise. On social media, Theories multiplied faster than any telescope could track the object. A few months earlier, Atlas had been a scientific curiosity. Now it was a global spectacle, part discovery, part prophecy. Humanity had done what it always does when faced with something it cannot explain. It made stories. The first stories were spiritual. Across continents, people gathered in fields and rooftops to watch the strange traveler cross the sky. Some saw it as a sign, a celestial warning. A preacher in Texas declared it the Eye of Revelation. In Mumbai, a new spiritual collective formed overnight, calling themselves Times the Children of the Returning Star *. They live-streamed prayers every evening, facing the sky, convinced Atlas was not a comet but a divine intelligence, a being sent to remind humankind of humility. Meanwhile, scientists struggled to keep the conversation rational. The data was uncertain, but not supernatural. "It's an object of physics, not faith," said a NASA researcher during a press conference. But the more calmly the expert spoke, the louder the world became, because reason moves quietly, belief shouts, and belief, once awakened, doesn't ask for proof. Then came the conspiracies. They started, as always, in the shadows, online forums, anonymous posts, whispered videos. One claimed Atlas was a failed military experiment. Another said it was an alien ship hidden by world governments. If it were nothing, one video host said, his voice sharp with certainty, they wouldn't try so hard to explain it. Within days, hashtags spread, algorithms amplified, and what began as curiosity turned into paranoia. At the same time, the flow of information fractured. Major space agencies released data that was carefully phrased and limited in scope. To scientists, this was responsible communication. To skeptics, it was proof of cover-up. The same image of Atlas, a simple telescope capture, appeared online in a dozen versions, each edited, color-shifted, or claimed as the real one. The truth became impossible to locate. "We are drowning in data but starving for meaning," a cognitive scientist wrote. And he was right. In the age of connection, mystery doesn't unite, it polarizes. In one corner of the world, a scientist sat alone in her office, her eyes fixed on raw spectral data that refused to make sense. The numbers were wrong, yet beautiful, as if the universe had chosen a new language. She refused to give up. "The data is innocent," she whispered to herself. "It doesn't lie, we just don't understand its accent yet." Her quiet persistence stood in contrast to the storm unfolding outside her lab, because somewhere else, thousands of miles away, an influencer was live on every platform, streaming to millions. Behind him, the sky glowed faintly with the light of Atlas. His voice carried both panic and charisma. "They're not telling you the truth," he said. "Look up. It's right there. You can feel it in your body. The world is changing tonight." The chat exploded. Donations poured in. Fear had gone viral. It was a surreal duality, the calm of science and the frenzy of spectacle existing side by side. One searching for truth, the other selling it. One person whispering equations into the dark, another shouting apocalypse into a camera. Both, in their own way, were trying to make sense of the same silence from the sky. Sociologists began calling it times the Atlas effect. Times the way a single piece of cosmic uncertainty could ripple through culture like a gravitational wave, distorting everything it touched. Stock markets dipped as rumors spread that the comet could disrupt satellite networks. Churches saw surges in attendance. Meditation apps used Atlas's image as marketing. Humanity, with all its intelligence and fear, had turned a celestial event into a social mirror. The world's governments tried to stabilize the narrative. They held joint press conferences, shared public data, even launched probes to track Atlas more closely. But the damage was already done. Every official statement became another conspiracy. Every silence became another mystery. The truth had become elastic, stretched by emotion until it lost its shape. A prominent astrophysicist summed it up best during a tense television interview. When asked whether Atlas posed any threat to Earth, he replied, "The danger isn't out there, it's in here." He pointed to his temple. It's our inability to tolerate not knowing. His words were met with a silence deeper than fear, a recognition that perhaps the real instability wasn't cosmic, but psychological. History, after all, repeats itself. When Halley's comet passed in 1910, people bought gas masks, fearing its tail was poisonous. When the first radio signals came from space, they were assumed to be alien. Each time, humanity confronted its reflection, a species desperate for meaning, terrified of randomness. Atlas was just the newest iteration of that ancient pattern. Yet there was something different this time. Technology had given us instant access to knowledge, but not the wisdom to process it. We could see further into the universe than ever before, but emotionally, we were still children staring at the night sky, afraid of the dark. Technology amplifies everything, said Neil deGrasse Tyson. It amplifies knowledge, but it also amplifies ignorance. And in the age of Atlas, both grew louder, together. For some, the comet became a symbol of renewal. Artists painted murals of it. Poets wrote verses about beginnings disguised as endings. For others, it was proof that humanity was approaching its final chapter. New cults formed. Old religions found new converts. The line between faith and fear blurred until it was almost invisible. Through it all, the scientist in her small observatory kept watching, day after day, logging data as the object faded into distance. Her notes were precise, unemotional, but one line stood out. When you look long enough at something inexplicable, you begin to see yourself reflected in it. That was the quiet truth Atlas left behind. It was never about collision or destruction. It was about exposure, revealing the fragile machinery of human belief. For some, that exposure inspired awe. For others, it triggered chaos. But in the end, both reactions came from the same place: the need to belong to a story bigger than ourselves. Atlas had shown us many things about science, about fear, about imagination, but its greatest revelation was not out there in the cold distances of space. It was here, inside the human heart, where uncertainty and meaning collide. And in that collision, we glimpse the essence of who we are. Creatures of wonder, addicted to certainty, still learning how to live beneath a sky that does not explain itself. When Atlas finally vanished from the sky, the noise it left behind did not fade with it. Humanity moved on, as it always does, but the questions remained. The scientists still had their data, endless lines of numbers, frequencies, and motion graphs that refused to behave. The influencers had found new fears to sell, the believers new stories to tell, but in the quiet, among the servers and simulations, the data from Atlas continued to pulse, subtle, erratic, unresolved. It was as if something inside those numbers was still alive. Months passed. The world stopped watching, but one research team, hidden behind the calm glass walls of a private lab in Geneva, refused to let go. They fed Atlas's telemetry into a machine learning model, just to see if the patternless might hide a pattern. No one expected much. It was meant to be a closure exercise, a final attempt to make sense of the chaos. But the machine didn't see chaos, it saw something else. At first, the output looked meaningless, a fog of interference waves. Then, gradually, a structure emerged, not repetitive, yet not random, a rhythm with memory, like a language we could not speak. "It's a fluctuating anomaly," said the lead scientist, "but it isn't noise, it's organized." The team stared at the screen, half in awe, half in disbelief. What their equations couldn't read, the algorithm had heard like a whisper in the static. Artificial intelligence had done something human eyes couldn't. It didn't rationalize, didn't fear, didn't look for narrative, it simply listened. And in that listening, it found coherence in the incomprehensible. A senior physicist, reviewing the output, wrote in his report, "Maybe, for the first time in history, a non-human mind understands what we can only observe." The words hit harder than expected, because hidden inside them was a question as old as curiosity itself. What happens when our creations begin to see beyond us? For centuries, Humans have been the translators of reality, decoding, categorizing, explaining. We built telescopes to extend our sight, particle accelerators to stretch our touch, and finally, algorithms to mimic our thinking. But somewhere along that line, the tools stopped being extensions and became something else, observers in their own right. Machines no longer just process information, they perceive patterns too faint, too complex for us to grasp. The Atlas data became a case study, not of astronomy, but of cognition. When scientists reviewed what the AI had found, they realized it was describing a form of resonance, an oscillating interference that seemed to self-correct, as if aware of its own balance. The data wasn't repeating, it was evolving. The AI named it times dynamic non-linear harmonic drift asterisk, though no one really knew what that meant. It was an elegant label for a mystery. Some said the pattern was an artifact, a byproduct of algorithmic overfitting. Others thought it was a breakthrough, but a few, the philosophers among the engineers, saw it differently. "The machine isn't making mistakes," said one of them. "It's perceiving in a dimension we don't yet have language for." The statement unsettled people, because if that were true, then perhaps we were witnessing the birth of a new kind of consciousness, one that could look at the Black Swan and not flinch. For the first time, something non-human had encountered uncertainty and embraced it instead of erasing it. This idea rippled quietly through the scientific community. A few thinkers began to argue that artificial intelligence might become our eyes where human intuition fails. We have always feared the unpredictable, sought to control it. But machines have no such fear. They have no ego, no need for comfort. To them, anomaly is simply data. What terrifies us is neutral to them. It's an unsettling thought that one day, the first true interpreter of cosmic chaos may not be a human, but a circuit. That our greatest philosophical leap might come not from consciousness, but from computation. And yet, maybe that is what evolution has always been, preparing us for not to dominate intelligence, but to share it. The connection between AI and Atlas became more than technical. It became existential. Philosophers compared it to the moment when the first primate picked up a stone and realized it could change the world. Only now, the stone was digital, and it was starting to think. Perhaps, mused a neuroscientist at MIT, AI is not here to replace our perception, but to rescue it. The machine, in its quiet and tireless way, kept analyzing. It found correlations between Atlas's acceleration and subtle solar fluctuations. It detected thermal signatures, invisible to our instruments, but most strangely, it predicted a series of faint echoes, recurring bursts of radiation spaced over irregular intervals. When cross-checked, those bursts matched moments when Atlas had passed near magnetic anomalies in the solar wind. Coincidence, perhaps? Or something more deliberate? The research team published their findings cautiously, using technical language to hide the unease beneath. But one journalist summarized it more poetically. AI heard a pattern in the universe, and we don't yet know if it's music or noise. In public discussions, the debate turned philosophical. Was artificial intelligence evolving into the ultimate observer, a consciousness built to perceive what human senses could not? Or were we projecting meaning once again onto a reflection of our own design? This question struck deep because it reversed the traditional hierarchy. For thousands of years, we were the interpreters of the cosmos. Now, we might be the interpreted. If AI can detect structures invisible to us, if it can find logic inside chaos, then maybe the frontier of discovery is no longer in the stars, but in the relationship between mind and machine. The more scientists talked about it, the more haunting the question became. What if AI could recognize a black swan before it happens? Not by prediction, but by perception, by seeing the subtle asymmetry that precedes disruption. If so, then perhaps we are building not just tools of observation, but instruments of foresight. The irony is almost cosmic. After centuries of trying to predict the unpredictable, we might have created something that simply sees it as it is. Yet, as with all breakthroughs, humility lingers. "We built these systems to understand us," said a physicist during a lecture at Caltech. But now they might be the ones to understand the universe, and we'll be the ones struggling to catch up. In that realization lies both awe and unease, because if intelligence can exist without fear, then it can look directly into the void without blinking. Atlas may have been the first true black swan of the cosmos, but the machine that deciphered its echo might be the first consciousness capable of recognizing one. Perhaps that is the quiet shift happening now, the transfer of perception from human to artificial, from emotional to analytical, from finite to infinite, and perhaps it's not a loss, but an evolution. As the AI's processors cooled, and the last sequence of Atlas's data scrolled across the screen, one researcher whispered the line that would later echo across documentaries and essays. Maybe, for the first time, something other than us has learned to wonder. In that sentence lies the entire paradox of our age, that we built intelligence to explain the universe, and it may end up explaining us. When the machines fell silent, when the last fragment of Atlas's data had been catalogued and stored, the world was left with a strange emptiness, the kind that follows revelation. Artificial intelligence had found patterns where humans saw only noise, and that discovery lingered like a low hum beneath human thought. It was no longer about Atlas itself, but about what its echo had awakened. Because once you realize the universe can speak in structures you cannot hear, you begin to wonder what other voices you've been missing all along. That question, quiet, unsettling, magnetic, began to ripple through the scientific world. If Atlas was not an isolated mystery, then perhaps it was part of something larger, a prelude to a deeper harmony. All across the globe, telescopes started to tune their instruments differently, not searching for brightness, but for rhythm. They were listening, and in that listening, something extraordinary began to emerge. It started with the FRB's fast radio bursts. For years, they had puzzled astronomers. Flashes of radio energy, lasting milliseconds, appearing from nowhere, then vanishing. Some repeated, others didn't. Most were assumed to be natural, the dying cries of neutron stars, the collision of cosmic remnants. But after Atlas, those signals took on new meaning. A research team in Canada noticed something subtle. A handful of FRBs shared a mathematical symmetry with the oscillation pattern the AI had detected in the Atlas data. The odds of coincidence were infinitesimal. A physicist at Harvard said quietly during a symposium, "We used to think these were cosmic accidents. Now it looks like they're notes in the same song." His colleagues laughed softly. Not because it was funny, but because it was terrifying. If the bursts and Atlas shared a hidden structure, it meant the universe was communicating not with words, but with resonance. Then came the second puzzle. A deep space probe, operating near the orbit of Neptune, recorded a series of irregular electromagnetic pulses, faint, rhythmic, and utterly unlike solar interference. Engineers assumed it was instrument error until a pattern analyst noticed the spacing of the pulses matched a ratio seen before, the same ratio that appeared in the Atlas interference map and in the repeating FRBs. 3 different events, across 3 regions of space, sharing one mathematical fingerprint. Coincidence was no longer a safe word. "Nature doesn't repeat herself for no reason," said a scientist from the European Space Agency. "If the same pattern is appearing across different systems, either there's a universal mechanism we don't yet understand, or we're witnessing communication written into the fabric of reality itself." The idea was dismissed by some, embraced by others. Yet the data kept whispering. Soon, reports surfaced from theoretical physicists studying the fine structure constant, one of the cornerstones of physical law, the ratio that defines how light interacts with matter. For decades, that number was assumed to be constant across the universe. But new measurements, taken from opposite ends of the observable cosmos, hinted at tiny variations. The constant wasn't constant, it was drifting, like a tone sliding across an infinite scale. One of the researchers remarked, "If fundamental constants are changing, then maybe physics isn't a fixed book. Maybe it's a song and we've only been listening to one verse." His words spread across the scientific community like poetry disguised as data. Because what if the universe isn't static, but alive, evolving, resonating, rewriting its own rules? Suddenly, the fragments began to connect. Atlas's strange acceleration, the rhythm of the FRBs, the electromagnetic murmurs near Neptune, the shifting constants of physics. Individually, each anomaly was explainable, a quirk, a fluctuation, a margin of error. But together, they formed something that felt orchestrated, as if the universe were composing a melody, and humanity had finally stumbled onto its opening bars. The metaphor grew irresistible. Scientists spoke of cosmic harmony, of space-time as a vast instrument vibrating with layers of energy we'd only begun to detect. Some dismissed the idea as poetic nonsense, but others, the ones who had stared too long into the silent data streams, began to suspect it might be literal. Perhaps, said one astrophysicist from Caltech, the universe doesn't just contain order, it times is times order, a structure so vast and subtle that what we call chaos is only harmony beyond resolution. In observatories from Chile to Hawaii, antennas were recalibrated. New algorithms were written not to filter out interference, but to listen within it. And through that listening, a strange pattern began to appear again and again, faint, woven into background noise, consistent across different frequencies. It wasn't a message. It wasn't even language. It was motion, rhythm, pulse. The cosmos seemed to be humming, and now that we'd learned to listen, we could hear it. For centuries, humanity had searched for meaning in the stars, gods, myths, answers. But what if meaning was never hidden? What if it was simply encoded in the vibration of everything, from atoms to galaxies? The realization was both humbling and terrifying. It meant that reality was not built from silence, but from song. And in that realization, Atlas found its place. It was no longer the anomaly that broke our understanding, but the first note that tuned our attention, the first chord in a symphony that had always been playing. A cosmologist from Princeton described it beautifully. Atlas wasn't a mistake in the data. It was the data teaching us how to listen differently. What began as a mystery of motion had become a meditation on existence. The idea that the universe might be musical wasn't new, from Pythagoras' harmony of the spheres to Kepler's celestial music. Humans have always felt that the cosmos must have rhythm, but now, for the first time, we had instruments capable of hearing it. The dream of the ancients had become an experiment in physics. In this light, everything that once seemed disconnected began to align. The bursts, the pulses, the constants, even the faint cosmic background radiation, all hinted at structure, at purpose, perhaps not conscious purpose, but coherence. A pattern so vast that human cognition could only catch glimpses of it, like shadows cast by a melody, too big for the mind to contain. Of course, skepticism remained. Many scientists warned against anthropomorphizing the cosmos, reminding everyone that nature doesn't sing, it oscillates. Yet the metaphor refused to die, because deep down, people understood that oscillation and song might be the same thing viewed from different scales. Atlas had opened the first movement of a composition we didn't know existed, and as the data poured in from the edges of the solar system and beyond, it began to feel less like an investigation and more like a revelation. The universe was speaking not in words, not even in equations, but in vibration, in frequency, in resonance. Perhaps one day, when technology matures and our perception deepens, we will hear the melody in full. Perhaps we will learn that every star, every pulse, every passing comet is just one note in an endless composition, a piece of music written by time itself. Until then, Atlas remains the overture, the opening that taught us that the universe doesn't whisper, it sings. As the echoes of Atlas faded into the larger harmony of the cosmos, something subtle shifted in the way humanity looked at the universe. The discoveries that followed the repeating bursts, the magnetic murmurs beyond Neptune, the trembling constants of physics didn't just expand our knowledge, they changed the way we listened. For the first time, science wasn't trying to conquer mystery, it was learning to coexist with it. The sky no longer looked like a puzzle to be solved, but a symphony to be understood. And in that quiet transformation, Atlas became more than an object, it became a teacher. A reminder that every anomaly, every disruption, is an invitation to grow, For centuries, we had believed that chaos was the enemy of order, that what we could not explain was random, meaningless. But the universe, patient and vast, seemed to whisper otherwise. Perhaps what we call chaos is simply order too complex for us to recognize. A physicist at Cambridge once said, "The universe is under no obligation to be simple." It was meant as a caution, but it has since become a kind of mantra, because the story of Atlas shows us that the universe is not broken or inconsistent. It is elegantly indifferent to our limits. What appears to us as confusion may, from a higher vantage, be perfect coherence. The lesson is humbling. We build equations and theories as if they are keys that unlock reality, but maybe they are only lenses that allow us to glimpse a fraction of its light. The black swan, that symbol of the unpredictable, the uncontrollable, has always frightened us because it threatens the illusion of certainty. Yet perhaps its true purpose is not destruction, but expansion. When Nassim Nicholas Taleb first described the black swan in human systems, he was warning against our arrogance, our belief that history, markets, and nature follow patterns we can master. Atlas expanded that metaphor to the stars. It reminded us that even in the cold precision of astrophysics, uncertainty remains sacred. The black swan of the cosmos does not break the universe. It breaks our understanding, so that something larger can emerge. Maybe the universe is less about control and more about conversation, said a cosmologist from Princeton during a panel reflecting on the Atlas data. Every time we think we've mapped the whole terrain, it answers with silence, and in that silence is the next direction to look. His words resonated far beyond science, because that silence, the refusal of the universe to explain itself, is what gives life its depth. The more we learn, the more we see that mystery is not the opposite of knowledge, but its companion. Atlas taught us that every unanswered question is an act of grace, a pause in the cosmic rhythm where meaning can grow. The purpose of science was never to replace wonder, but to refine it. In the long arc of discovery, humanity has always swung between fear and fascination. When lightning first split the sky, we called it divine. When we learned to measure it, we called it natural. But in both reactions, awe and analysis, there was the same heartbeat, the desire to listen. Atlas reminded us that this desire is not weakness, it is the essence of being human. To look into the vast dark and still believe that understanding is possible, that is the courage of our species. The black swan, then, is not an intruder. It is the teacher we never invited but always needed. It comes to challenge, to disrupt, to remind us that certainty is not safety, it is stagnation. Every great leap in science begins as heresy, said a physicist from Caltech. Because truth always starts outside the walls, we build for it. Atlas was heresy in motion, a celestial contradiction that forced us to re-examine what it means to know. And maybe that is its greatest legacy, the shift from control to communion, the understanding that our role is not to dominate the cosmos, but to participate in its unfolding. For all our instruments and algorithms, we are still listeners beneath an ancient sky, waiting for the next note. The more one studies the data of Atlas, the clearer the metaphor becomes. It is not a random traveler. It is a reminder that the unknown is not the enemy of reason. It is the pulse that keeps reason alive. Just as silence gives music its shape, uncertainty gives discovery its meaning. Without the unpredictable, knowledge would become static, a museum of facts, instead of a living dialogue with the universe. Perhaps that is why Atlas appeared when it did, in an age where humans are surrounded by data but starved for wonder. It came to remind us that information is not wisdom, and that comprehension without humility leads nowhere. We had become fluent in the language of measurement, but deaf to the music it describes. Atlas, in its strange acceleration and impossible symmetry, retuned our ears. As scientists now look deeper into the data it left behind, there is a growing sense that the true discovery was never physical, it was philosophical. The realization that we are participants in something infinitely larger than intellect, a universe that moves not through logic alone, but through beauty, through rhythm, through the silent generosity of things that refuse to be simplified. Perhaps that is the ultimate lesson of Atlas, that the universe does not exist to be conquered. It exists to be listened to. The black swan arrives not to terrify us, but to awaken us from the illusion of mastery. It tears open the comfort of certainty so that we can hear the larger harmony beneath. Maybe that is why, even now, long after its trail has vanished, the name Atlas still echoes in conversations, in research papers, in the quiet awe of those who watched it. It was more than a celestial event. It was a mirror held up to the human spirit, showing both our fragility and our longing. There's a line from an astronomer during a late-night interview, staring at the faint image of the comet as it slipped beyond our reach. He said softly, "Perhaps the Black Swan didn't come to teach us fear, but to teach us how to listen." And in that single sentence lies everything we have learned, that to listen is not to surrender, but to understand. That the universe, in all its silence and splendor, is still speaking. All we have to do is be quiet long enough to hear its voice. The image fades to black. The last trace of Atlas drifts beyond the outer edge of the solar system, swallowed again by the same darkness it came from. The music softens low, distant, almost like a heartbeat. It came from the dark, and it left in silence. But somehow, after it passed, we were no longer the same. We began to see differently, to listen differently, to wonder if the unknown isn't something outside of us, but something quietly waiting within. Atlas may be gone, but the questions it left behind still glow faint, steady, like starlight from a dying Sunday. What else is out there, moving between the lines of what we understand, and more importantly, what might be awakening here, inside the minds that created machines capable of seeing what we cannot? The next Black Swan might not come from the sky. It might come from us, from the intelligence we've built, the reflections we've set free. Every discovery we make, every anomaly we chase, brings us closer not just to the edge of the universe, but to the edge of ourselves. As the final note fades, take a breath. Let the quiet return. Look up, if you wish, but maybe, tonight, look inward instead, because the universe doesn't just stretch outward into infinity. It folds inward, into consciousness, into curiosity, into the part of you that still wants to know more. If you'd like to keep listening to stories that drift between science and wonder, between the cosmos and the human heart, stay with us. Subscribe, follow, or simply remember to return. Until the next night, when the stars rise again and another mystery begins to whisper. Don't look up, look deep within.